So this is Dr. R. Menaka, ASP, IT of Vellared College of Engineering and Technology, Europe. I welcome you for this session on the topic KNN algorithm. KNN nearest algorithm. K nearest neighbor is one of the simplest machine learning algorithm based on the supervised learning technique. KNN algorithm can be used for regression as well as for classification, but mostly it is used for the classification problem. So KNN is a non-parametric algorithm, and this KNN algorithm can also be called as a lazy learner algorithm. The KNN algorithm in the training phase just stores the data set, and when it gets the new data, then it classifies that data into a category that is not similar to the new data. Suppose there are two classes like red and blue, and we have a new data set point x1. So this data point will lie in either of these classes. So with the help of this KNN, we can easily identify the class of the particular data set. So let us consider the simple data set, which is of 7 rows alone we have it, and we have the 3 columns. First column feature represents the brightness, and second column represents the saturation, and third column represents the class. So based upon the brightness, some values, and based upon saturation, this category of point will belong to the red category. And like that, different set of rows are been given, and this is the data set we're going to use in order to understand the KNN working methodology. So having this as a data set, we can take down the graph, and in this graph, we try to plot the brightness, take the brightness values 40 as x1 and saturation values y1, and taking the x and y coordinate, plot the information, plot each and every data in your graph, and after plotting you may be getting the different two classes identification, that is one is a red and second is an blue, and the algorithm how it's working. First of all, you have to select the number k of the neighbor. That is, this algorithm say that is a k nearest neighbor. So first of all, you have to choose how many neighbor you are going to choose for predicting the new data entry. So now let us take the k equal to, it may be 3. If you choose the k equal to 3, you can choose 3 neighbor data entry. If you are going to choose 5 for k means, we can choose 5 data entries as a neighbors. Okay, then calculate the Euclidean distance of k number of neighbors. Then take the k nearest neighbor as per the calculated Euclidean distances. Among these k neighbor, so among this k neighbor, if I take the k equal to 5, among this 5 neighbor, count the number of data point in each category. So assign the new data point to that category for which number of the neighbor is maximum. And then our model is then ready to predict the new data set whether it belongs to the red category or to the blue category. So let us consider this is the new data entry for which we are going to predict whether this brightness values and the saturation belong to the red family or to the blue family. And now the new data set will be taken as a coordinate like x2 and y2, and the old data set, that is neighboring whatever we choose, that data point will be considered as x1, y1. So we have to use the Euclidean formula which have the work like finding the x2 minus x1 whole square plus y2 minus y1 whole square and applying the square root on this whole. So remembering the Euclidean algorithm, we have to, that is, as we taken k equal to 5, so we have to calculate d1, d2, d3, d4 and d5, that is the distance. Now how to calculate the d1 means, let us consider this is a row entry given. First take this row entry values like brightness and saturation and x1 and y1, and the data point which we are going to predict, take that as the x2 and y2. So apply this x2 y2 and x1 y1 in this formula, this different formula, and you'll able to get the d1 values like 25. Then again you take the second set row values and again you find out the d2 applying the equivalent distance, so you'll be getting 33.54. So like this, try to find out for at least 5 rows. So after completing 5 rows or maximum rows you just have it. Then, so as we selected k equal to 5, approximately selecting 5 is also enough for us. So now what you try to do, whatever calculated values for d1, d2, d3, that can be added in new columns like this. After adding this column, what you do, based upon the distances in ascending order, we arrange again this data set. So we have arranged data set based upon this distances. After arranging, again we remind the we choosing the k equal to 5. So let us consider only the 5 data entries with the new distances calculated. So now, um, whatever the new data is given, how to find out this new data entry belong to the red category or blue category. So what you do, just find out the count of the red category. Among this 5, how many red count is available, and among this, how many blue count is available, just calculate it. So according to this data entry, we have the 3 red count and blue 2, it has a 2 count. So maximum count belong only to the red class. So conformly we can say that the new data point um, will compulsorily belong to the red classes. So like that, any data point can be predicted after taking the k nearest neighbors. With comparing the k nearest neighbors, similarity measure, you can identify new predicted data set whether it belong to this class or that class. Thank you for your listening.